And you can try and work out which of those facts wasn't true in the break. Okay, so I'm here to talk about layout because that's what I talk about. And we've already been through some of the things that I do. That's where you can find me. You can find me on Twitter and on my own website at rachelchallenger.co.uk. And I guess really the important thing in the context of this talk is that I'm an invited expert to the CSS working group, which means that I help to make CSS, although you can't actually blame me for all of it. So I'm hoping that some of you here have heard a bit about this new specification, CSS Grid Layout. That's a new layout method for the web, and it shipped into browsers earlier this year, and it's just gone into Edge, which is great because I've been talking about it for about 5 years, and I'm pretty sure that some people were thinking that this was some kind of CSS vaporware that I was enjoying going around the world talking about. So I was very happy personally when it got out into browsers. And if you do front-end stuff, and maybe you've looked a bit at Grid, and you're sort of thinking, well, you know what, we've already got Flexbox. You know, Rachel, why don't you just use Flexbox? Why have we got this new layout method for the web? And defined in the specification is the most obvious reason. Flexbox is designed as a one-dimensional layout method. That's laying things out as a row or as a column. What does that mean? So that's a flex layout. So that would grow and shrink according to the available space in the browser windows, whatever your container's got. And if we've got fewer items, as on the last row there, then space distribution happens across the row, and they're kind of splitting the difference and spreading out across the row. And we can make them line up as a column by adding widths and things, but the sort of basic nature of it is that we're working in one dimension. So we're working in a row, so space distribution happens row by row. And this is the same kind of layout, but using grid. But here, the items are lining up both along their row, but also in their columns. And so they're sitting underneath the column above. And that's two-dimensional layout. We're doing a row and a column at the same time. And this is a key thing to remember with grid layout, and why we've got kind of all these new properties and things that we haven't seen before in CSS. Grid works from the container in. We create a grid, and then we put stuff into it. And every other method that we've had before, everything in the past, requires that you give the items in your layout a size and then kind of line them up to make it look like we've got a grid. So this is a simplified float example. If you've ever used a framework, if you've built a floated grid, or you've used a framework that uses a floated grid, it's doing something a bit like this, probably a slightly more complex version. So we've got a row wrapper that forces clearing, so things don't kind of pop up in the way that floats do. And then we use percentages for the columns, and we have to use percentages for the gutters. We're using a margin for the gutter. And then we might either work out the maths manually, might do it with SAS, or use calc as I am here. So we have to get the totals and add them up to 100%, and then we get a grid. But we don't get a grid. What we actually get is the appearance of a grid, because we've lined things up very carefully, doing all the maths ourselves to make sure that things line up and look like we've got a grid. And those Flexbox-based grid systems, they exist. But Flexbox works on the container, but when you do things on the container, it does it one-dimensionally, and so things spread out all over the place, and that's not what you want if you want a grid. And so we fix that by adding percentages to the grid items, by going back to kind of removing the flexibility of Flexbox and lining things up so that we get something that looks like a grid. And again, we end up with row wrappers usually. This time the wrapper ends up as a flex container. And then we have the width on the item or as a flex basis. And then we sort of line them all up. It's a bit better than the float-based grid system. Obviously, we don't have to do all that clearing. And we can use all the nice alignment things that are in Flexbox. So it's a bit of an improvement over using floats. But we're not really using Flexbox for what it's good at here. And that's all that space distribution. And we're still having to take control of the maths. So here we are doing the same sort of thing with grid layout. We don't have to do any maths. And so what happens on the item is basically a simple instruction as to how many tracks we need to span. We've created the grid, we've said how big we want the tracks to be, and then we just ask the items to span as many tracks as we want. So it's a very different concept. We're defining the size of columns on the container when we set up the tracks. And there's various ways that we can actually then start positioning things on the grid. But the sizing comes from the container, and we don't actually have anything else in CSS really that behaves like this other than multiple column layout, which also does a kind of thing where you say number of columns that you want or the column size, and that's worked out on the container, and the things inside fit into those columns. So all of our other grid frameworks, they create something that looks like a grid by controlling item size. And CSS Grid Layout, it creates an actual grid, and you put items into it. And so when we say that CSS Grid Layout is a native CSS framework built into the browser, that's what we mean. We've actually got a real grid system. And I think it's no wonder that people are a bit confused, and they keep sending me grid-based grid frameworks that essentially use row wrappers and are making grid one-dimensional again. And the reason that we created all of those frameworks and so on is because doing the maths of calculating sizing is really hard, it's error-prone, and it's really boring, and no one wants to be doing that stuff. And so we created all these frameworks that abstracted all that away and let us just pop a class on an item and say, you know, please be this size. And we don't need a lot of that with grid. The browser is doing that maths for you and dealing with the complexity. So every single abstraction that I've seen so far has actually taken away from grid layout. It's taken away from the specification and tried to force it back into this old way of doing things. So don't do that. If you're starting to think of, well, you know, I could make some kind of framework on top of grid, great, but make sure it's adding something and not taking away. And so it turns out that once we're dealing with creating size from the container, sizing becomes really important. And we've got a bunch of new sizing concepts to learn, and you've sort of seen some of that already in action. So to have as many columns as will fit into a container, that uses a couple of methods which have been designed for grid layout. We've got this repeat statement. So we can say grid template columns, and then we say repeat, and then the thing inside the brackets is going to be how many times we repeat it, and then we have a statement that we're going to repeat. So we can use this repeat syntax to save us having to write out lots and lots of tracks that were going to be the same. But here, rather than an integer, rather than a number of tracks, I'm using autofill. Because what I want is for the browser to fill as many tracks as it can get into that container, fill as many in as it can have. So we're using autofill. And then I'm using this min-max. Min-max is really, really useful because it lets us say, make something be a minimum size and then a maximum size. So it can be between those two things, which turns out to be very handy. In this case, I'm saying create a track that is at least 200 pixels wide, never get smaller than 200 pixels, but make the maximum 1 FR. And that means that any available space, the browser goes, well, I've got 200 pixels, 200 pixels, 200 pixels, and then there's this little bit left over. And the little bit left over gets spread out amongst the rest of the tracks, and so we end up with as many flexible size tracks as will fit in the container, but they'll never get smaller than 200 pixels. So we've also got this FR unit. And this is new for grid layout, and it's incredibly useful. It deals with distributing available space. So we can specify different FR values for tracks. So here I've got a 2FR track, and then a 1FR track, and a 1FR track. So the available space in the grid container is split into 4 and shared out in proportion. So we end up with something like this. And as the amount of space, if it grows and shrinks, then it just shares out in proportion. The nice thing about this FR unit, because we're dealing with distributing available space in the container, we can mix these flexible lengths with fixed size tracks. So here I've said, well, on my last track, it's going to be 400 pixels. It's always going to be 400 pixels. That's an absolute unit. And so we get this. That final track will always be 400 pixels. And then whatever space is left over is split between the two 1FR tracks. And so then we can create the 12-column example with the FR unit. We don't need to worry about the fact we've got fixed width gutters here, because before we distribute all that space, we take away the amount we need for the fixed width gutters. We don't need to use a sort of weird percentage in there. We can just take that away, and then whatever's left over, we share out between our 12 tracks, which is what gives us this, the column tracks detailed on the container. And this FR unit, a really common issue I see with people when they're sending me things they're trying to work out with grid. The FR unit, in most cases, will replace your need for using percentages in your designs. You can let the browser do the calculations for you. So you can use the FR unit pretty much like you would use percentages. The only reason I am using percentages in grid layouts at this point is where I'm adding a grid layout component to a layout that uses some other layout methods as well, where I've had to use percentages to get the look of a grid. And say I want to add a grid panel inside an existing layout that's using percentages. I'll use percentages in my grid layout so that all of the track sizes line up, with the old style and the new style layout. So you can still use percentages, you've still got them. But if you're doing something new, you probably don't need to use percentages. The FR unit will make things an awful lot simpler for you. And so that min-max thing, I want to go back to that because min-max is useful in all kinds of ways, as well as creating these flexible sized tracks. Now here we're making sure that our tracks don't get too small. We don't want them to get smaller than 200 pixels. We don't want them to vanish to nothing. So we're setting them as a minimum of 200 pixels. The other place this min-max is really handy is to be able to create very precise looking layouts that look like they've got kind of fixed height tracks in them. But then if extra content gets in, they can cope with that and they can expand to take it. So here's a look at that. I wanted to create a panel that's a bit like the sort of panel of photos you get on Facebook. So you get this sort of neat set of photos. But I also wanted to pop some text in there. And so I have this neat looking grid and then have some text in the grid as well. So that's my grid definition there for the panel. So I've got some column tracks. They're fairly standard, just using the FR unit. And then I'm saying grid auto rows, so the rows that are created automatically in the grid will have those as a minimum height of 200 pixels and a maximum of auto. So I'm highlighting the row lines there, and you can see they all grow to 200 pixels tall, which means I've got some images in there which then sort of stretch over and fill up the tracks. Now, of course, what happens when you design a very neat fixed height sort of track box is that it gets to the content management system. And someone's like, no, this is a very important, very long news item that we need to have in here. And so that goes in. And you need to be able to cope with that. The layout needs to cope with the fact you might have more text. We never know how tall things are on the web, typically. But if we add some content here, the box will grow. Because the maximum of that min-max is auto. And auto will look at the content size, and it will just grow and allow as much content to go in there as you want. The thing to note is that it's the whole row that's growing because we're working in 2 dimensions. So if one cell gets bigger, then everything across the row is going to have to get taller as well. So the image on the other side needs to cope. And I'm using object fit on the image there, so it will grow and it will just fill up the space. But that's something to consider with your layouts. If you're creating these layouts that are very tolerant of different amounts of content, you need to make sure that right across the row or right down the column, everything is going to cope with that as sort of part of designing with grid. And I can then nest another grid, because a grid item can become a grid container itself, just like a flex item can become a flex container. So I'm going to use exactly the same technique, but I'm going to add a caption. So I've made the figure actually a 2-row track grid, and causing the image to span over 2 rows. Then I place the caption in row 2, so it overlays the image. It's another thing with grid layout, we can layer things up. You can have more than one thing occupying a cell, and you just use Z-index to control that stack. So that has got a minimum height of 100 pixels and a max of auto, which gives us this. And I wanted to point something out here, that the caption on this image here is taller. It's got 2 lines, and that's fine. It's kind of coping because I've got that max of auto. But what it's not doing is lining up with the one next to it, and it can't, because it doesn't know about the one next to it, because the nested grid is an entirely new grid. It's not got relationship to the overall layout, and I will talk a little bit about that later. But first, I want to stay with sizing. Because we've got some new sizing keywords. They're from the CSS sizing specification, and we can use them on our grid tracks to actually start to allow content a little bit to affect the size of tracks. So we've got these keywords: min content, max content, and fit content. So if you size a track as min content, my first track here is sized with the keyword min content. And what happens when you use min content in track sizing is that the track, it will use as many soft wrapping opportunities as it can to try and get the content as small as it can possibly be without causing any sort of overflow. And so we get a track like this. And you can see that that track size has essentially been held up by the word content, because that's the longest word in that track at the moment. So it's gone as small as it possibly can, and that's happened all the way down the track. So max content will do the opposite. So use the max content keyword, and essentially it will all spread out. It won't wrap at all. So it'll keep on going. If you've got a great long sentence in there, it's going to keep on going and spread out to be as long as it can possibly be, and that's going to be the size of that track, which of course may well cause overflows. If you haven't got enough space in the container, that's going to break out of the box. So that's max content. And so you can see that line is now spread out and taken up as much space. It's got as big as it can possibly be. But then we have fit content. And fit content is really useful because we can pass in a value. So fit content will act like max content. It'll spread out as much as it can until it gets to the value that you've passed in, and then it will stop. So it means you can have a track size. So you say, well, I'd like you to be max content. I'd like you to be as big as you can be unless you get to this point, and that's going to be too big, so I'd like you to stop there and just start wrapping as normal. So we've got two tracks. The first two tracks in this definition are using fit content, and this is what happens. So the first track, if that went to max content, it would be much bigger than 200 pixels, so it stops at the 200 pixels. The second one has only got a single number in it, and so it just displays at that size. It doesn't go to 200 pixels because it doesn't need to. It's just max content. They're really useful, and I think that there are really interesting possibilities in terms of design by looking at playing around with the size of things, using these kind of content keywords, using min-max. You do some quite interesting things with your grids. You don't just have to make a 12-column grid. You don't just have to make a set of little boxes. You can use this to create a framework that you put your design into that can really be quite creative and look at the sort of content you've got when making those sizing decisions. So that's all really neat. However, we do still have old browsers, and if I don't talk about them to you, then you will come and talk about them to me later. So let's deal with that now. So, old browsers. The nice thing about new CSS specs is that the CSS working group know that old browsers exist. And defined in the spec is how things deal with a new layout method being applied to something that's also using an old layout method. So if you use float or clear, so if you create a grid by floating things, and then you turn those floated items into grid items, the float and clear properties just get thrown away. You don't need to do anything to overwrite it. It will just naturally be overwritten by CSS. So here, I've got a floated item, and then it's become a grid item. It's no longer floated. Same is true with inline block. If you use inline block to line things up in a kind of grid format, you might know that you get the white space issue where things have a bit of space between them if you use inline block. If it becomes a grid item, that all just goes away. It stops being an inline block item. You can just do that. Do one, then do the other. It'll just work. Using things like display table cell, if you need to support very, very old browsers, I do in my own product, we support back to IE9, so we use table cell quite a lot along with Flexbox to try and create older browser support. If you turn something into a table cell and you get the anonymous wrappers, you get like a table row anonymous wrapper. If it becomes a grid item, that stuff doesn't happen. You don't end up with anything strange lying around sort of virtually that's going to cause you a problem. So you can quite safely use display table cell as a fallback for grid layout. And the reason we use things like table cell and inline block is that gives us vertical alignment with vertical align top and so on. If you've used the vertical align property for your older browser layout, and then it becomes a grid item, that just also gets thrown away. It has no effect, and so you can use the box alignment stuff, which is in grid layout, quite safely. And don't forget multicol. If you've got, for instance, a layout which is like a set of boxes or a set of images or whatever, multicol can be quite a useful fallback for grid. It's going to usually lay things out column-wise rather than across the row, which is what you'll probably normally be doing with grid. But it's a reasonable fallback. And so if you set column count or column width on a container and then afterwards say display grid, those column properties just get thrown away. It'll just overwrite it quite naturally. And of course, Flex Layout. Flex Layout is supported further back than grid is. So you can potentially use Flexbox as a fallback. And then again, if the flex item becomes a grid item, the flex properties of flex basis, flex grow, and so on that are applied to the item, they just get thrown away. They won't be a problem in your layout. What this means is you need to use the cascade. You need to understand how CSS actually works and how things actually work in CSS so that you can write your old stuff, write your new stuff, and kind of understand how that is working and that you're doing something that will work in browsers. However, there is a problem with this approach, because sometimes there's something in your old layout that will be interpreted by browsers that also support grid layout. You can't just rely on overwriting. And a sort of typical thing is if you've set a width. So here I've got a floated item. I have floated it and I've given it a width, which is what you have to do. We've already seen you have to line things up by giving them a width. And then I go and turn it into a grid item. And what's going to happen is that floated item is now going to become 33% of the grid track, as opposed to 33% of the available width, which is obviously not what we want. But CSS has also fixed this problem for you with feature queries. Feature queries are wonderful. They are going to become your new best friend. They have got really good browser support, and you don't need to worry about IE11 not supporting them, because what you do with feature queries is you write your old CSS, and then you have your feature query, and you write your new CSS inside that overwrites the old stuff like this. So here I've said, I've got my floated item, it's 33%. Then inside my feature query, I just say, set that width back to auto. And so the feature query is at support, so it's a bit like a media query. I'm saying, do you support display grid? The browser says, I do indeed. Say, right, set that width back to auto, and that's all you need to do. Feature queries, fantastic. And anything new in CSS that happens from now on in, you can use a feature query to detect. So what this means is you do need to understand CSS. If you're at all foggy about how the cascade works, how the fundamentals of CSS works, this is a really good time to just sort of relearn that and make sure you understand. Because the actual fundamentals of CSS aren't fast-moving. This stuff hasn't changed a lot. I've been doing this for a very long time. You don't have to learn everything about every specification, but those real core fundamentals are worth understanding so that all this new shiny, you can really take advantage of it. Now, very quickly, I just wanted to go through some things that we might have next in grid. Now, we saw that problem of the items in a nested grid not lining up with the rest of the sort of items in other grid cells because they were separate sort of grids nested inside. And this is a really good example of why we might want a specification called subgrid, which was actually removed from the level 1 spec because it turned out it was very complicated to work out what to do with grids that were nested all the way down. So this is sort of an idea around that we're thinking about. So this is a layout. And this is the sort of layout that you get from a designer who believes that content emerges from the CMS with perfect line lengths. So everything lines up really neatly, doesn't it? And we can use grid really easily to look at that and say, that's really easy with CSS grid. There you go. There is your grid layout that will do this. And then, of course, the real world of real data happens, and this happens. And the designer says, that's not what I wanted. And you're like, I know. And so we think, well, I'd like to line those boxes up across each row, and we can't because the internals of the box aren't participating in the grid layout. And about the best we can do is something like this. We'd make the internals a nested grid, we'd make them a flex container, and then we could push the footer down to the bottom, which is a bit better, but your designer's still going to say, that's not what I wanted. So we've got this subgrid spec that was pushed into level 2. And it could solve this problem. We'd basically need to look at what our internals were. And what we've actually got is a 4-track grid, if that was the internals of the box, with all of the items in there. And so what we'd need to do is, on the card, we'd say, well, you need to span 4 tracks to make room for the internals, and then say display subgrid. And the idea being that then the internal things would use the grid defined on the parent, which would give us this sort of thing as in this mock-up. And in reality, we'd also need to deal with the gap because the spec that we did have didn't really have any concept of the gap and so on. Now, this is all completely theoretical at the moment. And the spec that was sort of come up with was quite limited, and that was one of the reasons it was pushed into level 2. But there's a fair bit of discussion happening about how we do this, how we can define a grid on the parent and let not just direct children, but the children of children and even their children also use that grid. There's a bunch of stuff. I'm showing these slides later. You'll be able to have a look. There's a bunch of stuff. There's also an issue on the CSS Working Group draft repository where we're talking about this. If you have use cases, come and share them. Another thing that people want to do, they start using grid layout. They say, oh, this is just like Masonry. And it turns out it's not. So it looks, we do this sort of thing, and people think, yeah, that looks a bit like Masonry. That kind of works a bit like it. And then we have auto placement. And we can take a bunch of things, throw them at a grid layout, and grid will just lay them out for you, which is lovely. And you can even cause some of those items to span multiple tracks, which is pretty cool. So we end up with this kind of thing. But we've got these gaps in the track. And then we can use grid autoflow dense. And grid will backfill the gaps. And people are like, yeah, this is Masonry. Surely this is just like Masonry, but it's not. It's still a strict grid with rows and columns, and things are also ending up out of source order if you use autoflow dense, which can obviously cause accessibility issues. If someone was tabbing around that, they could be jumping all over the place. So that's not ideal. So Masonry layouts look a bit more like this. Items stay in document order, so they'll go across the row. And kind of what happens with Masonry is you get a layout, and then you have a gap, and so you sort of push items up into the gap. It's almost a mixture between grid and Flexbox, a sort of a two-dimensional weird Flexbox thing. It's a little bit different. So currently, you're closer to Masonry with multiple column layout, except that you're going column-wise. Now, this is something we'd quite like to solve because it comes up again and again and again, and there is a giant thread on the CSS Working Group draft repository about Masonry layouts because it is the thing that everyone seems to want to be able to do. So that's something that we'd like to discuss, and we'd like to figure out the best way to achieve that. So if you've got thoughts, come and join in with the giant thread. It does show that there is interest and that people want to do this sort of stuff. And so those are really just two things that we're thinking about as we start to use grid, because I was talking about this for 5 years, but just like everybody else, I'd not used it in production until March. And it's when you start to use things in production, you see problems and challenges and stuff that, oh, it doesn't quite do this as I thought it would. So this is new to all of us. And so we're finding the edge cases and we're finding the problems. And we're still figuring this stuff out, and we're all learning this together. And so if you do start using grid layout or any new CSS and you hit problems, you find something you think, oh, why doesn't it do this? Why doesn't that work? Well, share what you found out. Write about it. Come and tell the CSS Working Group what's missing. As I say, everything is there on GitHub. There are issues raised against the specifications, just like any open source project. And we're very, very happy for people to come and comment or raise issues, and it will get discussed. And you may well come up with something that will get added to a CSS spec in future. And that's exactly what's happening. People are bringing their feedback, and they're actually getting added to specifications. This is your platform to create on, and we want to make more things possible. That's a really cool thing about this. And if grid was pretty new to you, I've got a bunch of worked examples on gridbyexample.com. I also created the guides for MDN, which is lots and lots of words about grid layout. There were videos on my site on Grid by Example, and lots of other thoughts on rachallen.co.uk. If you do run into problems using grid layout that you think this is a bug, I've got a set of grid bugs that I'm collecting, and also trying to get them fixed. So we find the bugs, and then we go and log them with browsers and say, hey, let's get this fixed. It's surprisingly interoperable, grid layout, considering it has just landed in browsers. There are very, very few bugs, but obviously there are some. And let's try and get those sorted out. And as mentioned, if you like this sort of stuff, I've got a book out with a book apart, which is all about layout and really puts grid into context so that you can sort of see how it fits with other layout methods. And all of my slides and resources are at that URL. Thank you very much for listening.